Hello student. Hello, how are you? And in today's video, we're looking at something interesting, which is the organic chemistry. Are you so confused? And you're just so tired? On what area will I look at? In this organic chemistry, I hear students complaining, I don't understand what the lecturer is doing. I don't know what the lecturer is doing. I don't even know what is even trying to do. No, you don't have to get yourself confused. And in today's video, I will take you through a step-by-step process, and I'll be highlighting essential topics and what you need to know in the topic. By the mercy of God, if I am helped, if the time will permit me, I will try to highlight what you just need to know. And if you just know it, that's all. Organic chemistry is the simplest part in the chemistry of IJMB, and with the highest allocated mark and with the shortest time, because there are basic things they just want to, is a test of IQ, intelligence. It's not a test of what you've read. No. It's just, do you have an understanding on this, right? So let's just proceed. Now the first topic here I'm going to encourage students to know before they get set for their examination is hybridization. SP1, SP2, SP3 hybridization. You know, there are tricks: single bond, SP3, double bond, SP2, triple bond, SP3. Those tricks does not work in all cases. And if you want to know the cases whereby they don't work, check my video on my channel. I have explained where the tricks do not work. So they just want to understand if you can identify hybridization. And there are little things again they want you to know on hybridization, which time will not permit me to speak. But if you want to know, you can check the description and chat to me directly. The second one again on my list, you should be able to identify intermolecular forces. Now, what they will do is, there are specific things we look a compound and we could able to trace which one has an intermolecular forces. So in IJMB, they'll just replace series of compounds and they'll tell you to identify the intermolecular, which of this compound has an intermolecular forces. As you can see on the screen, that's what they will do. As simple as that. You should be able to understand in a compound which bond is polar and which one is not polar. That is to say, polar compound and non-polar compound. For the tricks, highly electronegative element forms a polar bond. So your lecturer had explained a lot of things, but when you just see, you should be able to know which ones are the highly electronegative element. The members of group 7, the member of group 6, that is oxygen, fluorine, chlorine, when they are being attached to any other element, maybe from group 1, group 2, or group 3, just know that because of the presence of those highly electronegative elements, it becomes polar. And you see, they'll just, it's so sweet. It's the most simplest. I just love organic chemistry. They'll just give you a list of compounds and then ask you to identify which one is a polar bond. Just know the group 7 and group 6 members. If you just see them there, know that is a polar bond. So, but it's beyond that, but that is the most simplest trick to arrive in there. So the next one is IUPAC nomenclature. IUPAC nomenclature, yeah. IUPAC nomenclature, yeah. I had shared some previous videos about my study pack. There is IUPAC nomenclature on the study pack. Please, if you have not gotten it, try to check the description and get it. You should be able to know how to name compounds, organic compounds. It is repeated. In this 2025 especially, you will see it. Get ready. It's not a prophecy, but I'm telling you, you will see it. Because I noticed from my study, looking at the past questions and the trends, I noticed it's going to come this year. So be ready for it. Get ready. So you should know IUPAC nomenclature. And the fourth topic is, now mind you, whatever I'm listing out here is what you should be expecting. Is what you'll be expecting for your 2025 examination. My fourth on my list here is isomerism of alkanes, isomerism of alkenes, and isomerism of alkynes. Please go and learn isomerism. Cis and trans. Try to know it. There are tricks to it. Yeah, there are tricks. I have taught some. Check my YouTube channel. There are tricks to arriving at isomerism. There is a trick I use. How will you know that if it is, for example, decane? How can I know the isomer of decane? If pentane, how can I know the isomers? Because sometimes you say we have 3 isomers of this, we have 4 isomers of this. Now there is a formula. It's just a shortcut to by any one. They just say what is it? Just draw the isomer of this. With the help of my trick, you can know how many isomers you have to draw out of it. So check my videos on my YouTube channel. If you can't find it, try to reach out to me, and I will bring a help to you by the mercies of God. So the next on my list on the topic you have to know is identification of a functional group. Yeah, they'll bring out series of compound and try to identify the functional group that is present here. Is it alkana? Is it ethene? Is it alkanol? Is it ethanoic acid? You get, those are functional groups. You should be able to know their symbols, and you should be able to identify it in the compound when it is present there. So students who are not serious, they won't know, but it's very simple. So please try to know these things. They will be helpful to you even in your undergraduate program. So the next on our list is understanding different types of reaction. Yeah, there are a lot of reactions, so I will not deceive you. A lot of reactions: oxidation reaction, reduction reaction, Cannizzaro reaction, Haddock condensation. There is what we call Wood's reaction, Markovnikov's reaction. We have a lot of reactions. The ones I can't even remember: Haddock condensation. We have a lot. There are a lot. I cannot release them. But if you want me to make provision for the reactions, well, of course I can do that. Now you should know addition reaction. Now the trick is, to every reaction there's a particular product that is formed. How do we identify it? For addition reaction, something for the product, there is a particular thing you will see in the product that you know is an addition reaction. For reduction, there is something we will see at the product that will make us know that is a reduction, is a redox reaction. Now for Markovnikov's, there is something we see that makes us know that it is Markovnikov's. Now, what do they do in IJMB? They can ask you to complete the forward reaction, or they can easily say, identify which of the reaction took place here, and they'll give you a series of reactions. Now, with the knowledge, you see that they are not asking you to come and do one. I know mechanism normally comes out if they want to, but these are the basic ones, just to test your knowledge. If you know when redox took place, oxidation took place, Cannizzaro took place, Haddock condensation took place, hydrogenation, halogenation. You just want to know if you know when this took place. If you can differentiate them, if you can identify them, you are good to go. To provide you with series of reactions, your own job is to identify them. And if you don't know that, please at the comment section tell me that I should make videos on the basic reaction you need to know for 2025 to get you ready for your upcoming examination. So the next on our list is, can you guess? Okay, let's keep the video short. The next on our list is identification of primary, secondary, tertiary carbon atom, or they will tell you to identify the type of compound. Is it primary? Is it secondary? Is it tertiary compound? Now this one is simple. When it is attached to a single carbon, it is primary. When it is attached to a double carbon, it is secondary. Attached to 3 carbon, it is tertiary, and so on and so forth. Now if you don't know that, please you can also reach out to me and just make a list and say, among all these are the things I don't know, and I'll make videos for you. But nevertheless, you can check my YouTube channel, but if you can't find it there, you can as well reach out to me. Number 8 is, okay, I've already explained number 8. It's just what happened in oxidation and reduction of alkanoic acid. I explained it in number 6, but let me see, add to that. So number 8, you should know what happened. Now if you check your 2024 past question, you'll see this thing came out. It's part of the question. So a student should be able to know what happened in oxidation. When oxidation reaction take place, what happened? What really took place then? When reduction of alkanoic acid happened, what will it be reduced to? Will it be reduced to alkanol? Will it be reduced to ethene? You get, when reduction take place of alkanoic acid, alkanones. If alkanone is reduced, when redox reaction take place in alkanones, will it be reduced to what? Is it alkanoic acid? Is it alkanone? You get, when alkanoate is a redox reaction take place, what will it be reduced to? Alkanoic acid, anhydride, and so on and so forth. You should know this. This is just the simple thing they just want you to know. It's not about studying the whole lot of work and get yourself crazy. No. That is not it. It's just simple trick, simple IQ test, and IJMB becomes simple. So let's look at the next one. The next one is number 9. You don't have to miss this. I'm suspecting that this may eventually come out, which is halogenation of alkanes. Halogenation of alkanes. What happened in the halogenation of alkanes? There are about 7 reactions, right? About 7 reactions. You should be able to do that. You should be able to draw those. You're able to write out those reactions. The next one is, and the last one for today's video. I wish I could tell you more, but if you stick to this, I can assure you, you can score 50% or more, 50 to 70%. If you can stick to this closely, you should be able to score 50 to 70% in your upcoming examination. The last one is resonance. You should know canonical structures. You should be able to know resonating structures. Resonance in benzene, resonance in cyclic chain. What happened? That benzene pi electrons are taking in different positions. Now these are resonance. So a student by now should be able to identify and to draw resonating structures. And if you don't know that, check my videos. And if you still confused, you can as well reach out to me. Check my description or contact me, and feel free to reach out to me, and remain blessed. So do not forget to subscribe. It's necessary. Share, like, and also reach out to other students. Thank you so much. God bless you. I've started. You don't want to subscribe, right? You don't want to subscribe. And it does not bite. It doesn't bite. Where is that button? Where is it?